All right, kid, let's look at your isomerism. Guys, for isomerism, right? Okay, so we always have, okay, for stereoisomerism, come boy, what's it? Same structural formula, but okay, but a different arrangement in space, yeah, remember that. Okay, I think we have some new kid here. New kid, do you have this note, new kid? New kid, please download your note here, new kid. Okay, so guys, remember these are same same structural formula, but different arrangement in space. Okay. All right, guys, nice. So there are two different type of isomerism, especially your stereoisomerism. We have cis-trans. Okay, the name for cis-trans is also known as geometrical, yeah. And we have optical. That's it. All right, guys, if you don't want to write arrangement in space, I can also write it as a spatial arrangement, yeah. Okay, now then you have to know, right? Good. All right, guys, the first one, let's look at the cis-trans isomerism. So, guys, for cis-trans isomerism, right? Okay, so how you picture it is always there is no free rotation about your CW1 here. All right, guys, a good example, right? It's this one. Okay, so the double bond, right? You cannot just twist and turn them up. Okay, so this double bond, you cannot just twist and turn them. For example, right, I can have a compound that looks something like that. Or I can have a compound that look completely different arrangement. Okay, so these two type of isomer, we call it as a cis-trans. How? Printed, yes. Okay. All right, guys, now. Okay, let's look at your cis-trans isomerism. Kid, how do you visualize or how do you picture this cis-trans, right? Okay, so I want you guys to see it as a stickman dancing. I put it as a dancing stickman, yeah. Okay, that's how I visualize this. So, kid. Okay, so try to visualize it this way. I have a stickman here. Okay, this fella must have abs, yeah. Okay, and guys, now let's picture it as either you can put the hydrogen as your hand or CH3 as your hand. You have to choose your hand. So let's say if I choose my H as my hand, right? You see this fellow is doing a dance like that. Let's see. Okay, so do you see a big C? So this we call it as a cis isomer. Clear? Okay, and guys, for the second stickman, you see, right? It's a totally different isomer. Why? Let's look at your hand. Bro, you are doing this now, bro. Like, let's see. Like that. Yeah. Ding, 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 ding. You're doing this dance move now. So when your hands are in opposite direction, we call this as a trance. Remember, cis trance is just different stickman dancing. That's it. Yes. Oh shit, no pen. Yo, okay, take the pen. Where you came from? Where you came from? Golf. Golf some more. Yo.
Red pen.
Red pen can as long as it's a pen, right? Better than nothing, right? Okay. Alright, guys, now let's continue. Dun, 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 dun. Alright. So in a cis built two in, guys, always remember a cis, right? It's always like a big C. Okay, so your hand, right, should be on the same side. Okay, so cis is always same side. But for trans, it's always opposite side. Okay, so trans position opposite. Alright, guys, now let's continue. So these two isomer, right, have different spatial arrangement. Remember that, yeah? The spatial arrangement is different. That's it. Okay, so they have different biological activity. This is so I think this is only come out in your A2. This you don't need to know. Different biological activity and different physical property. Which means their melting point might not be the same. Alright, guys, next. Alright, guys, this part, yeah. For cis isomer, trans isomer, I don't care. I don't want you guys to copy this. It's okay. Thank you so much. One for this, my boy. Okay, then skip. Don't care. Now, this part, skip everything. Nothing you need to know. Alright, guys, now let's continue. Alright, guys, again, right, I'm going to give you some study tips here for you to identify a cis trans. So, guys, in order for a cis trans to occur, remember this, you must have a C double bond C. Okay, you must have a C double bond C, must be present here. Okay, so this is the first criterion. When you see a C double bond C, then it might have a cis trans. Clear? Alright, guys, next. The second thing is, kid, let me ask you a question. You just imagine, right? Cis trans is basically a dancing stickman. iPhone. Type C. Yeah. Oh my god, I have everything, bro. A second. C. Here. Type C. This one is. Yeah. You want to check here? Alright, guys, second. Okay, I want you guys to write it down. Carbon on each hand, yeah. Okay, carbon of each end of your C double bond C must not connect to the same group or atom. Alright, guys, this you need to know, yeah. Okay, so carbon on each end on C double bond C must never connect to the same group or atom. Alright, guys, now let's look at this, yeah. Can this show a cis trans? You have to tell me, yeah. Draw this out. Can this show a cis trans? Okay, so if you look at it, guys, these two groups are the same. You can see that. They are the same, right? So no cis trans. Okay, so you see, there's no hand, guys. Okay, this one, the reason why, right? There's no hand. Can see that, right? Kid, let's say if I were to draw a stickman here, where's your hand, bro? You have like three hands. Like what the hell? You have like what? One hand like that, then another hand like that. So again, cannot. My cis trans must be either this stickman or this stickman, understand? Okay, but you see, there's no way you can draw this here. Where's your hand? You cannot find your hand. Bro, what's this? Choo, choo, choo. What the hell is this? 10. All right, guys, next, second one. Let's draw this. All right, guys, look at this. Can it show a cis trans or not? Please try to answer my question. Yeah, this will prompt you to think further. Would it show a cis trans? Yes or no? All right, guys, the answer is this does show a cis trans. Okay, this can show a cis trans on one reason, guys. Why? Because you see, this part and this part are not the same. Can see that? And this also not the same. Clear? Okay, so I can draw my statement like that. Deng, deng. Can see that? So this fella is doing a cis. Okay, so that is a cis trans. Okay, guys, next. All right, now the next thing is, guys, I want you guys to write this down. In a ring, if you see a ring, right, there's no way a C11C can show a cis trans. Okay, so guys, please write down in a ring, there is no way, okay, a C11C can show cis trans. Okay, please write down. Okay, tunggu. All right, guys, let me ask you a question. Let's look at this. Okay, can this show a cis trans or not? A C11C in a ring. A ring is, yeah, correct. The answer is no, kid. You see, right? If you were to draw a stickman, guys, just imagine this. Where's your hand? Just imagine, right? Your purple color is your hand. Bro, your hand is held tight. Can see that? Bro, basically you are like, your hand's like binded. I mean, you're like doing a ballet, bro. There's no way you can do a cis or a trans. This is a cis. This is a trans. Just imagine in the ring, right? Your hand is like held tight, like binded. And see, you cannot do the dance now. There's no way you can do a cis trans. Okay? Remember that, yeah? Clear? All right, guys, now let's continue. Okay, I want you guys to look at this part of my study tips. Okay, guys, any isomer with more than one double bond. Okay, so if it's asymmetrical, I can use 2 to the power of n here. Okay, n stand for number of cis trans. Okay, so guys, if it's asymmetrical, then sorry, there's no way, right, you can identify. So for asymmetrical, okay, you have to draw it out and identify. Okay, please write it down. All right, guys, let's go. Okay, list down the total number of isomer for each of the compound. All right, guys, let's do this question now. All right, guys, I'm going to give you guys another 1 minute. Please try this question. I'm going to start discussion soon, yeah. All right, guys, let's go. First question. Kid, can this show a cis trans or not? Yes or no? Can this show a cis trans? Yes, of course. Can you see a stickman? Do you see this stickman? Okay, so you can either draw a cis isomer or you can draw a trans isomer, right? So the answer is 2 isomers, correct? Done. Clear? Alright, guys, second question. How many total isomer? Come, I need answer from you guys. Go. How many isomer in total? Anyone? Joe boy, how? Huh? Not a lot, but you have a few. None. Not quite right. No. Alright, guys, again, look at my double bond. This is my double bond, right? F is here. Hydrogen, hydrogen. You can draw a stickman here, correct? Guys, can I draw a stickman here? Yes or no? No, bro. Your hand is held tight. Correct or not? So basically, it's 2 to the power 1, which is 2 isomer. 1 cis, 1 trans. Done. Get me? Yes,
This number of isomers.
Yeah, total number of isomers. Okay, guys, next. Part C. Let's go. This is so ugly. Alright, guys. So this one, right? Is that a cis trans? Yes. I can let any two to be. Do you see that these two are not the same? These two are also not the same. As long as it meets this condition, I can randomly put any two as my hand. So 2 isomers in total. Alright, guys, next. Okay. Hey, guys, last one. How many isomers in total? How? Why only got 2? Why only 2? Because you can see, you can either draw this or you just imagine a guy, cis trans is always drawing stickman. I can draw a stickman that looks something like that. I can also draw a stickman that looks something like that. Which look, this is here. This one, I can put my F down, Cl, CH3, C2H5. Like that one. Do you see 2 isomer? Now, this one or this one? 2 isomer. Understand? Okay, next one, guys. I'll see ya. Bye-bye. Alright, guys, the last one. How many isomer? How many cis trans can you find? So, guys, do you see? I have 1 here. The first stickman. Where else? Second stickman is here. Correct or not? Get me? So the answer is 2 to the power of 2, 4 isomers. Clear? Huh?
No.
Okay, guys. Again, isomer is stickman. Please, I don't want you guys to overthink it. It's just stickman. Please use the stickman method if you cannot visualize. It's very simple. Give me a name. This is Nadia and Joe Boy. You see, let me show you a 4 isomer. Nadia, do this. Joe Boy, do this. The first one. What else? Nadia, do a cis. Joe Boy, do a trans. Second one. What else? Nadia, do a trans. Joe Boy, do a cis. What else? Nadia, do a trans. Joe Boy, do a trans. It's that simple. Guys, if you're not following, if you are not using the correct method, it's damn difficult for you. What I want you guys to do is use my method, picture it as stickman. Now I want you guys to rephrase everything, picture a stickman. How many different arrangement of stickman you can do? That's it. It's just a game. Okay? Not hard. Get me or not?
So the F as T.
No lah. Oh, even your F as H also can what? Can, because as long as this and this are not the same. Can already. As long as these two are not the same, then okay already. Alright, guys. Now, can picture yourself. Why that's 2 isomer? Because I can draw a cis or I can draw a trans. Get me or not? Why is 2 isomer? This I can draw it here. Or I can flip this position, right? So you can draw a trans here also. Get me? Okay, so cis trans is just a stickman. Understand or not? Clear? Yes, huh? Alright, guys. I'm gonna increase the difficulty. Please look at. Okay, I'm gonna give you one more question. I want you guys to draw it here. Alright, guys, please tell me how many isomer you will be getting. If you can do this, I'm proud. Go. Alright, guys, any answer? Please try. Anyone? Picture a stickman, guys. Picture a stickman. On where you can draw your stickman. 4. 4. None of you guys got it right.
Easier than you think.
Huh?
Is it easier than you think?
It's easier than you think.
Eight.
If you apply the correct method, not 8. Cannot be 7.
6.
Oi! Now you guys are not making sense anymore. You guys are guessing. Walao eh. 0. Wrong. None of you guys got it right. Bro. For cis trans, please reduce the difficulty. Drop it to 0. Drop it to level 0. Reconstruct your mind. Declutter everything. Don't overcomplicate. Use my 16 GG. Okay, I'm done. GG. Guys, please. This is just drawing stickman. Guys, can you draw a stickman here or not? Please tell me yes or no. Can you draw a stickman here? No, why? You got 2 arms on the same side, bro. What the hell? You're like doing this. I say cannot do this. What the 216? This is not a stickman already. Get it. Guys. What the hell? No. Second one. Alright, guys, can we draw a stickman here? Yes or no? The answer is yes. Why? Look at this carbon. This and hydrogen are not the same. Correct or not? This and this are not the same. As long as they are not the same, it's okay. I can draw it like that. Draw it like that. This can draw a stickman. Guys, last one, can draw stickman or not? No, why? Hydrogen, you are doing this again. What the? Let's see, it's that simple. So how many stickman? 2 to the power of 1 stickman. 2. None of you guys got it right. GG. Hey guys, this is very important. Your cis trans, you must be very good at it. Yeah. Okay. By the way, this is not even level 10. this most probably is gonna be like level 3. Okay, guys, I'm gonna show you one more question. Please, I want everyone to get it right. If you're not getting it right, I'll be damn mad. That's it. Guys, this is your level, this is exam style question, yeah. If you can't do it, means you are overthinking. Remember, what did I mention about stickman? What did I mention about cis-trans? It's just stickman. If you understand the concept, it's just stickman. Yes, thank you. You see, some of you guys already getting it. Remember, stickman. Think about where you can place your stickman or where you cannot place your stickman. That's it. Okay, don't overcomplicate. It's just stickman. Okay. I'm making it damn easy for you guys already. If you are using the complicated method, means GG. Okay. If you use complicated method and you get a correct answer, yes, okay. But if you use complicated method, wrong answer, not okay. Is it 9? 9. F9. 2 to power what equals to 9? Log base 2 to power 9. Oi. Oi. What 9? How 9? Wrong. Can never lock it. Yeah, lock it, right? I was about to say lock it. Oh yeah, what lock? Stick man. Alright, guys. Any answer? Joe boy, go. 4. F4. F8. Guys, any answer? Okay, your cis-trans is quite important. Okay, unfortunately. Okay, any other answer? No more? Not everyone get it right still. Okay, we're gonna start looking at double bond. Alright, guys, look at double bond first. Look at this. Can stickman or not? Can stickman or cannot stickman? Cannot stickman, bro is doing what? Dragon Ball. You don't Dragon Ball, please. No, I don't like. Cannot. Off. This one, can stickman or cannot stickman? Can, right? Why? Because one of it is H, another is this ding ding. Okay, these two are not the same. These two ding dong also not the same. Yes, this I can draw a stickman. Wee. Dun 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 dun. Correct or not? That's the first stickman. Guys, here can stickman or not? No, bro is doing a ballet. I say it. Okay, must be assist or trans. Cannot Dragon Ball. Cannot ballet. Okay. Yeah. Nope. Also GG. What about this? Can do stickman or not? Also Dragon Ball, bro. HH. Cannot. Last one. Here cannot. Can, right? So the answer is only 2 to the power of 2 stickman, 4 isomer. Easy. Clear. We haven't done optical yet. Wait, hello. Please. Remember, no Dragon Ball. Bro, I'm going to put it here. No Dragon Ball. Don't Dragon Ball me. No Malay, please. If your stickman does look like this, it's definitely GG already. Or stickman does look something like a Malay, also GG. Please, you can only do this. I want a sexy cis or a sexy trans. That's it. Simple as that. Okay. Don't overcomplicate the concept. It's just like that. Okay. Okay, guys, done. Let's go. Okay. So whatever that we have done so far, this is considered level 6. No, level, I would say in 1 to 10, right? This is considered a level 5 question. In exam, you might get a level 7 to level 9 question. Okay, so if do re mi fa so you cannot do, right, means GG already. Level you automatically you are a B student or maybe C student. Okay, this one you must know how to do. This level A student you must as an A student you must know how to do. Okay, guys, my height fails, right, when you have a symmetrical molecule. Okay, guys, symmetrical molecule you cannot use 2 to the power of n no more. 2 to the power of n, right, is GG. If it's symmetrical, 2 to the power of n will get you GG answer. Let me tell you why. Okay, you need to understand the concept behind. Guys, let's draw a hepta 2,5 diene. Let's go. Hepta 2,5 diene. 1, 2, 3, 4, 5, 6, 7. Alright, hepta 2, 3, 4, 5 diene. Correct. 1, 2, 3, 4, 5, 6, 7. That's it. Alright, guys, fill up your hydrogen. Okay, this is your hepta 2,5 diene. Yeah. Please draw your hepta 2,5 diene first. Alright, guys, now let's look at it. Kid, where is your stickman? So, guys, do you see that for this molecule, right? Okay, there is a symmetrical point. You see, right? I can put a mirror here. Just imagine, right? This is a mirror. You are dancing to yourself, Give me a note. Okay, so which means your left hand side and your right hand side, right? They are the same. You see or not? They're kind of same one. Okay, so basically you have a mirror. Okay, you see your left hand side and right hand side are the same. We call that symmetrical molecule. So guys, how do you picture a symmetrical molecule, right? The trick is I have a twin doing a dance. So this is a twin. I put Brad and the twin brother Brad. Alright, so basically two same person. Okay, twin brother doing a dance move. Okay, so guys, yes, I do have 2 stickmen, but by right, I do 2 to the power of 2, 4. The answer is wrong. It's not 4. Why? Okay, guys, come. Let me show you how. So in exam, okay, use stickman method to do it fast. Alright, guys, you see, I have Brad. Brad wear spec one. Shit, how Brad look like? Brad no spec one. Got hair one. Draw your body first. Draw abs for you, some more. Oh, this is gonna be art class today. Yes. Alright, guys, now let's look at the first way these two fellas can dance. Come, please tell me. So I can make them do a ding, do a cis. Correct or not? That's the first one, which is shown here. Can see, right? Okay, what else? I can make these two fella do a, what you want? One cis, another one do a trans. Okay? Third one, I can make this fella do a trans, do a cis. Last, do a cis and a cis. That's where your 2 to the power of 4 come from. Hey, 2 to the power of 2 come from. But
Trans, last one.
Sorry?
Last one is trans.
Hey, sorry. Last one is a trans. Thank you. Last one is a trans. My bad. Okay, so you see, right? So basically, I put bread and bread together. These are the dance move that these two breads can show me. But out of the 4, 2 are the same. Which one? So guys, these 2 are exactly the same. Why? Because if you read it this way, it's a bread cis, bread trans. Get me or not? If you read it this way, it's still a bread cis, bread trans. Get me? Okay, due to the fact that they are the same person. You read it left, right, read it right, left, you see the same thing. So they are the same. So you have 1 isomer, 2 isomer, 3 isomer in total. Get me? Clear? So guys, again, when you have a symmetrical molecule, your total number of isomer will drop by 1. You have an odd number. Okay, understand or not? Sure. Boy girl, yes. This is not covered in your school, I'm pretty sure. This came out in exam, quite popular. I don't want you guys to lose mark here. Yes, if your school teacher done it, means your school teacher is like, 10 out of 10. Yeah, if your school teacher never done it, it's okay. It's never in the syllabus anyway. Suddenly pop out in the exam and you need to think like that. Okay. Yes, Hey guys, do this question for me. Go. Alright guys, answer please. I go refill my water when I'm back. Please get me answer, yeah. See you guys. Alright guys, answer please. How? Yes. My friend, what you answer? B. C. Okay, I have B, I have C. Who's right? Alright, guys, if you can get it right, I'm proud. Means you really understand the concept. If you get it wrong, means GG. Means your stickman not very sexy. Yes. So guys, let's go. Alright, guys, for you to picture it, is this a symmetrical or not symmetrical molecule first? That is your first question to ask yourself. Not symmetrical, man? Sure. I think it's symmetrical though. Can see this is where my mirror is. CH, CH, double bond, CH, 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 double bond, CH2, CH2. Shit. It's symmetrical, which means it's the bread and butter story again. Yes, it's symmetrical. Remember this, first thing to ask yourself, hey, symmetrical already, GG boys. Alright, guys, next. Look for your stickman. Where's your stickman? Alright, guys, is this our stickman? No, bro, this is doing Dragon Ball. What is this? Cannot. This one cannot, please, don't do this, Okay, if this miss GG already, cannot. Out. This one, also cannot. So, guys, where's your stickman? It's in the middle. Wee. Wee. But, guys, this question and the previous question is the same. It's Nadia and Nadia. You know what I mean? So, you and your twin sister. So, I can do this as my first, this as my second, this as my third. This and this are the same. On one reason, symmetrical. Get me? Go here and go here are the same. Can see that? Answer is 3. Oh, yo, finally. Thank you, Sun Long. Thank you. I love it. Yes, guys, please participate. For your info, this from past year. I never created this question. Okay, all the question that I've discussed was from past year. Yes, was your exam question, someone else's exam question. So please, okay, know how to do it. Understand your six trans now. Six trans is just drawing stickman. Remember my stickman method. Yes, no, no, yes. Alright, guys, 1 hour now. We're gonna take a break. Give you guys a break. About how many minutes? 2, 3, 2, 4. 2 minutes. Then we're gonna move on to optical. Yeah. Alright, guys, let's go. Okay, no time to waste. Let's continue. Let's go. Alright, guys, for optical isomerism, okay, what we have a molecule that contains a carbon bond that is bonded to four different groups or atoms. Remember, yeah, for optical, it's four different groups or atoms. Done. So it can form two optical isomer. These two optical isomer are mirror image of one another, yeah. Okay, mirror image of each other and it's non-superimposable. Okay, so guys, what do you mean by non-superimposable? Okay, means like a non-stackable, non-stackable. Like your right arm, right hand, left hand, you see? Okay, so if you were to place them, they are like a perfect mirror of one another, but you cannot stack them. If you try to stack them, your thumb will end up on top of your pinky will end up like, nah, it's just your middle finger is the only finger that's stacking. Okay, so none of the other four fingers are stacking. Okay, so non-superimposable. So the carbon atoms with four different groups attached is known as chiral center, yeah. Alright guys, a good example of how do you draw, right? You have to draw out a mirror image. CH3, ding ding ding, able. Walao eh. So guys, you have to draw a 3D mode, yeah? So please draw a 3D model. Okay, and you put your mirror line here. This is where this your mirror, this is where your mirror gonna be. Mirror. And okay, you have to draw a perfect mirror, yeah. Dun, 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 dun. Just do a reflection, okay? Yeah. Okay, that's it. Alright guys, give me a second, yeah. Alright guys, thanks. These two molecules are optical isomer, sometimes referred as. So for optical isomer, right, we also call it as enantiomers. Good. Alright guys, now let's continue. So for organic molecule that has more than one chiral center, so the total optical isomer, right, may be represented by 2 to the power of n, yeah. Okay. Alright guys, now how do you find your total isomer? Remember, yeah, your total isomer, we can use this formula, 2 to the power of n. And guys, n stands for the number of a stickman plus a chiral center. Okay, 2 to the power of n, number of cis trans plus chiral center. All right, guys, next question. All right, kid. First two questions, please tell me how many compounds found. First one, what's your answer? 2. Not quite right. 4 is correct. All right, guys. This is your first stickman, correct or not? Wee. Okay, and guys, do you see a chiral center? Not chiral, not chiral, not chiral, not chiral. This is your chiral center, yeah? Because 4 different group, OH, F, H, and this ding dong, none of them are the same. So 2 to the power 1 cis trans plus 1 chiral, 4 isomers. Get me? Let's go. Second question. All right, guys, answer for second question. How many? Anyone? Okay, I have 2 chat coming in. 8. All right, guys, let's go. First stickman. You see a trans. Second stickman. You see a trans again. Lastly, chiral center. Correct. So 2 to the power of 2 cis trans plus 1 chiral center, 8 isomer. Well done. Getting better. Good job. Okay, nice. Okay, guys, next. Let's see. How many? Try. 2. 0. Cannot be 0. Guys, can never be 0. Okay, if no isomer means alone, means the only compound it is already drawn. So it must be, the minimum is 1, cannot be 0, 1, yeah. Answer? 1. Okay, guys, is there any cis trans? No, this fella is doing a ballet. This fella is also doing a ballet. So no cis trans and no chiral center, 1 isomer only. Well done. Guys, you're getting better. Well done. Okay, guys, last one. Flip to the previous part, which is page 21, question 3. Go. Guys, please get this right. Hopefully you get it right. One. Okay. Try. Four. All right, guys. I hope you guys get it right. Really, please do it nicely. I have 1, I have 4, which means I have either A or C. A, donkey. Okay, A, C, D. Wow, like everyone did like that. Wow, B times 2. Shit, man. I have answer from every option also have answer. Means, let's see who's right. C. C times 3. Okay, so C. So A times 1, B times 2, C times 3, D times 1. Who's right? Yeah. Well, you can change on. You must tell me why. You must tell me how. Alright, guys, please tell me how many stickman first. We do stickman. How many stickman? Get the stickman right first. How many stickman? 1. Guys, can this do a stickman or not? Cannot. This fella is belay, right? I said cannot belay. You don't belay, please. This fella is belaying, bro. No. This one, can see chance or cannot see chance? Can, of course. So, guys, minimum is already 2. So, A is definitely out from the table. 2 to the power 1 is already 2. Cannot be 1. Alright, guys. A, GG already. GG. Okay, now 2, 4, 8 still in the option. Guys, this must be a double bond C. This C, oh, right, bro. This fellow is like what? No hands, bro. What? This what? Handicap, brother. This fellow got no hand, bro. It's like, no hand. Handicap. Cannot. Okay, so cannot dance. Handicap. Okay, what else? Okay, how many optical isomer? How many chiral center are you looking at? Is this a chiral? No, up the same. Not chiral, not chiral, not chiral. Is this a chiral? Yes, it is a chiral. Okay, do you see a chiral? Why? Hydrogen, left hand side, right hand side, bottom. How? It's never the same. Correct. Guys, double bond can never be a chiral, not 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 a chiral. Correct. So which means 2 to the power of 1 stickman plus 1 chiral, 2 to the power of 2. Answer C. Booyah. Well done. This one, let's draw it out. On top is a hydrogen. This ding ding, this dong dong, and this ching ching are the same or not? Can see they are all not the same one. Can see, right? Wait, why is bottom C double bond C not cis trans? I just mentioned you draw your cis trans, can draw stickman, man. Where's your hand? Bro, your hand is like that. Held tight, bro. You're doing a ballet. Your hand is like binded, bro. Where's your hand? Draw your hand. You see your hand? You see your hand? Like that. How to cis trans? You know, ballet, no Dragon Ball. No handicap. Okay, so this one is a ballet. This one is a handicap. Cannot. That's it. Getting better. So guys, well done. I have at least 3 kids got it right. Yes, sure. All right, guys, let's continue. Last one. Page 25. Let's go. Please. Please. I hope everyone get it right. Let's go. Okay, D times 1. C times 1. Okay, means one of you guys is wrong already. GG. Joe boy, how? C times 2. C times 3. A times 1. See? So who's right? Bernice says C times 4. D times 2. C times 5. Okay, guys, let's go. Let's discuss. First, guys, can this show a cis trans? Yes or no? Think about it. Look at the double bond first. Yes or no? How can it be yes? This fella is Dragon Balling, bro. Wee! Look at the hand. Draw your hand. How can your hand be like that? I said already, you cannot have 2 hands on the same side, bro. This is like, what the hell? Come on, bro. Look at your hand. That's not your hand, bro. Okay, out. Second one, can this show a cis trans or not? This is definitely a yes. Can. Dun, 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 dun. Ha. Can this show us a cis trans again? Also yes. We have done 2 stickman. 2 to the power 2. Answer is definitely more than 4. So 4 could still be right. Okay, next. Chiral center time. How many chiral center? Joe boy, how many chiral center? 1. Not a chiral, not a chiral, not a chiral, not a chiral. Is this a chiral? Yeah. Hydrogen on top, left, right, not the same. First chiral found. Not a chiral, not a chiral, not a chiral, not a chiral. Is this a chiral? No. Left, right, the same. So 2 cis trans, 1 chiral, 2 to the power 3, 8. Answer C. Boo. Can. Okay, if you still cannot do, you do revision yourself lah. Mantap. Understand or not? It's like that only. Don't overcomplicate. Unless it's symmetrical, then do the bracket, do the twin -1. Okay. Okay, guys, basically you are considered a master now. Let's continue to the last part. Characteristic of, okay, so let's look at this part, page 27 now. Characteristic of organic reaction. So guys, for organic reaction, so whenever we look at any organic reaction, right, what we are okay, how a reaction occur, it's always either we are breaking a covalent bond or forming a covalent bond. So it's always breaking or forming a covalent bond, yeah. Okay, so guys, so there's two ways a covalent bond can break. It could either be a homolytic fission, okay, or it could be the heterolytic fission, yeah. Alright guys, now let's look at your drawing for your curly arrow. Kid, when you are drawing a curly arrow, which we'll be doing it later on, if I'm doing a curly arrow like that, a full curly arrow is showing a transfer of 2 electrons. I remember that, yeah. 2 electrons or 1 pair of electron is being transferred. Alright guys, if I'm doing a half-headed arrow, okay, this is a transfer of 1 electron, yeah. Okay, just one single electron is being transferred. Done. Alright guys, there's few ways a covalent bond can break. So guys, if you have a covalent bond, the electron is here. Okay, so the bond can be broken by 1 electron going to the left, 1 electron going to the right. So will result in a bond breaking. Or the same thing, but this time there is a difference in electronegativity. Both electrons go to the same atom. This will always result in bond breaking. Okay? Okay, guys, let's continue. Alright, kid, how to show a forming of a covalent bond? I can bring one half arrow, another half arrow, come together, then turn into a bond. This is bond forming. That's it. Alright guys, now let's continue, yeah. Okay, let's look at the homolytic fission, guys. So for homolytic fission, right, okay, so remember that this is when each atom take one electrons back, yeah. So a breaking of a covalent bond whereby both atoms take back 1 electrons with unpaired electron. Okay, so guys, this is how we draw it. So you see, right, we have electron here, electron here. So 1 electron go to the left, another electron go to the right. Okay, so this is when a gay couple break up. You take your stuff, I take my stuff. Okay, so eventually left 2 free radical. 2 very dry guys is formed. So this we call it as free radical, guys. And guys, this free radical, right, is very reactive. Okay, so a gay couple break up, you take your stuff, I take mine. 2 very dry guy. Yeah, Joe boy, you and your boyfriend break up. You take yours, Then he take his done. Okay, and you get free radical is formed. Alright, guys, next. Free radical Cl are very reactive. Remember that. Why? Because it has an unpaired electron, which is represented by the dot, and is very reactive. Done. Alright, guys, next page. Alright, kid. Now what we have is heterolytic fission. So hetero, when you see hetero means different, yeah. Okay, so heterolytic fission, you have uneven breaking of covalent bond, whereby two electrons goes to the same atom. Okay, so in heterolytic fission, the more electronegative atom is gonna take both electrons away. Okay. So guys, a good example is C with a Br. Do you see that this fella, it's a guy and dating a girl. And this fella, okay, the Br is more electronegative, toxic fella. Okay, so when this couple break up, then the toxic fella gonna steal both electron away. Toxic fella be like, whatever is yours is mine now, boom. Both electron go to Br. Then eventually, C, after breaking up, I left with a positive charge, and Br carry the negativity with him. So you have a cation and anion is formed, okay? All right, guys, now let's continue. All right, kid, in this case, as the bond break, okay, what we have, Br atom will take both the electrons away, forming a bromide ion. Okay, and this type of a cation, for example, if you have an Lq cation, we call it as carbo cation. That's it. All right, guys, now let's look at my study tips. I'm speed running this part because it's not very important and it's easy. Okay, we have two different fission. We have homolytic fission versus heterolytic fission. Okay, so always remember for homolytic fission, right, it always forms a free radical. Remember that, yeah? A free radical is produced. Okay, and guys, usually, right, both atoms must have the same or similar electronegativity. Example, right, can be Cl bonded with a Cl, Br bonded with a Br. So they have similar electronegativity, then they will undergo homolytic fission. Okay? Okay, please write it down. All right, guys, next. The next part, right, it's a heterolytic fission. Guys, for heterolytic fission, okay, it doesn't form a free radical, but it forms a cation and an anion, remember, yeah. All right, guys, next thing is the more electronegative atom. Okay, so the more electronegative atom, right, okay, will take both electron away. So for example, Cl will take both, F will take both, O will take both. Okay? Okay, guys, please write it down once done. We're moving on. Let's go. Alright, guys, next we have free radical nucleophile electrophile. Let's go. So, guys, let's look at phile. What do you mean by phile? Phile means love. For example, pedophile. Brad, pedophile. What is phile? Phile means love. Okay, so pedophile love kids. Nucleophile love nucleus. Okay, so you see, nucleophile love nucleus. So any nucleophile, right, are electron-rich species. Yeah, they have a lot of electrons. So that's why they are attracted towards proton, right? Sorry, that's why they are attracted towards nucleus, which is positively charged. Okay, so nucleophile are electron donor, and a nucleophile donates a lone pair. So a nucleophile can also be understood as a lone pair donor. For example, nitrogen has a lone pair, Cl has a negative, O has a lone pair, nitrogen has a negative, O has a lone pair. So it either have a lone pair or negative charge. Can see that? So that is the criterion for it to be a nucleophile. Okay, please write it down. Alright, guys, next. The next part, we have electrophile. Today class until 10:30, of course. Of course. From now on, every class until 10:30. Yeah, because this is the exam year, my friend. Alright, guys, next we have electrophile. Look at electrophile, yeah. Phile means love. Electrophile, love electrons. So which means love negative. So electrophile is an electron deficit species, which means it doesn't have enough electron. Okay, it doesn't have enough electron. Okay, so it accepts a pair of electrons to form a new covalent bond, and electrophile is usually found as a cation. Okay, and it accepts a lone pair or electron from a nucleophile. So you see, all the electrophile have a positive. That's it. All right, guys, next. We have free radical, guys. What is a free radical, kid? So for free radical, right, are atoms or molecules that have at least one unpaired electron. Alright, guys, example, we have Cl and methyl free radical. Guys, okay, I want you guys to look at it, yeah? I'm going to draw the outermost electron. Okay, by the way, a methyl free radical is a methyl CH3, like that. So guys, out of these three, right, I want you guys to label which one is a free radical, which one is electrophile, which one is nucleophile. Let's go. And guys, once done, we are done with this chapter. Yes. Alright, guys, the first one is what is it? Electrophile, correct. Second one, a free radical. Last one, nucleophile. Okay, let's look at electrophile versus nucleophile. Alright, guys, for electrophile, remember that electrophile love electrons, love negative. And electrophile are cation, yeah. For nucleophile, they love nucleus, which means they love positive. And they either have a lone pair or a negative charge. That's it. And yeah, we are done with chapter 13. Super long.